friends, J-Dub here. Hey, over the last few meetings, we've had a lot of questions that involved brew house efficiencies and hitting targets on the fly, things of that nature. And so I just suggested to the board that maybe we do a couple of presentations that explain these processes in detail. So anyways, I was supposed to be there tonight doing this presentation in person. However, I'm running late if I'm going to be there at all tonight. So I just thought I'd make this video. Hopefully it helps out. Tonight's going to be about brew house efficiencies. Next month, we're going to do one on designing a grain bill and hitting gravity targets on the fly. So hope this helps. So hopefully after watching this presentation, you'll have a good idea of how to go home and figure out the efficiency of your own brewing system. Now to do that, we need to cover several topics. It starts off with yield expectation. Then we want to show you a guide of just general fermentable ingredients that you use on a regular basis and what you can expect to get out of each one of them. We'll talk about brewing efficiencies for both extract and all grain, and then talk about the efficiency of extraction and what you should expect. And then hopefully we'll have time for some questions. So what is meant by yield expectation? Really, it's talking about, how much extract is available in any particular source. And really what we want to identify first is what is the maximum fermentable material present in any source. So how much, basically how much sugar can I get out of any type of grain or DME, LME, sugar, whatever you're using. So this is an interesting slide. What this data shows is the maximum extract potential of each of these fermentable sources if a pound of it were mashed and in some cases simply dissolved into 1 gallon of water. So if one were to take a single pound of Pilsner malt and mash it in 1 gallon of water, the maximum yield they could achieve would be between 1035 and 1037 depending on the malt source. Another example that many of us have done is use DME to make a starter. If one wanted to make a 1 gallon starter with a gravity of 1042, according to this graph, they would simply need to dissolve 1 pound of DME into 1 gallon of water, and there you have it, 1042. So from here, why don't we take this into more of a real world scenario? Let's start with you extract brewers. The first thing I want to do is for everyone is just introduce the acronym PPG, which stands for points per pound per gallon and is reflected in a whole number. So a specific gravity of 1040 would simply be 40. Okay, so let's say we're brewing an extract brew and we're using DME to do it. We design our brew just the way we want it and set the OG precisely at 1050. So how do we achieve that? The brewer, knowing that they were going to use DME to make their beer, could then simply take his gravity target, in this case 1050, and turn it to a whole number, so 50. From there you would multiply it by your volume, say 5 gallons, and then divide by the PPG of their source, in this case DME. So the equation would look like this. 50 times 5 equals 250 divided by 42, which is the maximum PPG of your DME source. So 50 times 5 equals 250 divided by 42 equals 5.95 or 5.95 pounds of DME needed to hit this target precisely. What type of flavors you wanted would of course determine on what type of DMEs you would use, but that's a topic for another meeting. Okay, so let's try to apply this same logic to all grain brewing. Today I'm brewing a German Pilsner that I do from time to time, and we're going to be basing our example equations on it. As you can see, we're mashed in. This is 15 pounds of Pilsner malt, 2 pounds of Carapils, and 2 pounds of Vienna, and it is soaking in 6 1/3 gallons of water, and I've already added a lactic acid addition to drive down the pH. Okay, so unfortunately, for all grain brewers, it is not as straightforward as brewing with extract. To get in the ballpark, an all-grain brewer can use the general guidelines we gave on slide number 4 and written down in countless books. How to Brew, Designing Great Beers by Ray Daniels. They all have these graphs in them that show you what malt does what, right? So if he or she wanted to be precise, however, they must get the information sheets from the maltsters. On that sheet, one will not only find specific yield of a particular type of malt, but the maximum yield for a specific lot of grain. So what field or area of the country that it was grown in, right? However, the information given on the maltster's information sheet is not in a PPG, and so we must convert it if it's going to be any use to us. So let's talk about converting what the maltsters give you to PPG. So what is found on these malt analysis sheets? The calculation we're looking for is called percent extract fine grind dry basis, or FGDB. And it refers to the maximum soluble extract a malt can yield when mashed. So why don't they just reflect it as a PPG number for us? Well, I guess that would be too easy. Okay, so how do they determine the percent extract? Trust me, you don't even want to hear the full explanation. So here's the Reader's Digest on this one. They perform a mash in a laboratory called a Congress mash, which is a very precise process. This test mash gives them the before mentioned percent extract fine grind as is, or FGAI. What does as is mean? It refers to the moisture content left in the grain after it is kilned and needs to be considered, as it can range from 2 to 10%. The weight of the moisture must be accounted for to properly calculate a malt's extract. The basis of comparison can be different, especially from European maltsters, but the parameter seen most often is fine grind dry basis, FGDB, which refers to a malt oven dried until no moisture remains. And yes, that was the short version. Okay friends, it's about 15 minutes now, and so what I've done is I've taken a small sample of the mash and I have chilled it down, because please remember that when you're measuring pH, your pH level is going to be different at a higher temp than it is at room temperature, and pH calculations are always done at room temperature. As you can see, we're at 5.2 right now, and that is yeah, really look, the temp is really in the 80s. Look at that, 87 degrees, so at 5.2. So our pH is perfect at this point for our enzyme conversion, and that is really going to help us out with our efficiency. Okay, let's get to the shit that really matters now. Converting percentage extract to PPG, right? The percentage extract number on the information sheet from the maltster simply refers to the percentage of the malt that is soluble. Most brewers, including commercial ones, but especially home brewers, will never get the maximum yield from any malt. But by knowing the maximum, we can now figure out what we commonly hit on our own systems, and that is your system's extract efficiency. So it's important to note that a pound of sugar, sucrose to be exact, yields 46 ppg. And more importantly, it yields 100% of its total potential, meaning that every bit of it that you put into the water turns into a fermentable source. Well, that is always the standard for which we compare all other fermentable materials. If sugar is 100% and 100% yields 46 ppg, then there you go, there's the standard. So whatever the percentage of extract of our malt is, we simply multiply 46 by that percentage. The result is the maximum yield of that malt. For example, if we have a two-row malt whose FGDB is 81.7% by weight, we would take 46, the maximum possible PPG of any fermentable source, multiply it by 81.7, and the result is the maximum yield of the two-row. Okay, so let's talk about how sparge rate affects efficiency. The slower you sparge, the more likely it is that you're going to rinse off all those sugars that you have created during your mash. So let me show you what I do. Okay, so I fly sparge, and I think, you know, if you read all the books, the difference between fly sparging and batch sparging is minimal. And so whether you batch sparge or fly sparge doesn't really matter. Let's talk about, we'll talk about each one here. So I fly sparge, which of course is maintaining the same amount of water in my mash tun as I am draining out of it. Right? And the reason why you want to do that, of course, is because you don't want to create any channels in your grain, which will take down your efficiency, because if the water is channeling down one area of your mash tun, then you're only rinsing that area, right? You're not rinsing your entire grain bed. And so that's why you want to keep the same rate on there, and you want to keep a nice, amount of water on top of the grain bed. You can see I have a couple of inches, all the way around on my grain bed. So, and I'm just keeping that the same. So anyhow, I am sparging at a rate that will give me about 1 gallon every 5 minutes. So, in a 10-gallon batch, where I'm coming up with 14 or 15 gallons of pre-boil, you can see how that, adds up considerably. In fact, for a 14-gallon batch, or that's something that I start 14-gallon pre-boil, would take me 1 hour and 10 minutes to sparge off my mash tun. And so anyways, but my efficiency is super high. My efficiency might even be in the in the low 90s. Today I've calculated my efficiency at 89%, and so that's the number we're going to be using for our base. Okay, so for those of you who are batch sparging, that process, in my opinion, is just as efficient as fly sparging. I batch sparge for a long time. I was able to lock in my efficiency rate on that system, no problem. The only suggestion that I would have is after you drain off your initial runnings and you pour in your first batch of sparge water, be sure that you stir up your grain bed up with that sparge water, and then wait about 15 minutes and let that grain bed settle. You're going to get a lot more sugar off your grain that way, and then repeat that process over and over again until you have the volume that you're shooting for. So we're in the home stretch here, folks. It's important to keep in mind that maximum yield is a value you might get if all mash parameters are perfect and converted 100% of all the present starches. There are a lot of variables, and the more you tweak each one of them in, the higher you'll push your efficiency, but maybe even more important, the more consistent you'll be with your brewing. All of these parameters are important for your mash. I want to tell you a personal story of mine. When I started paying attention to pH, I got an increase in efficiency of 10%. I went from like 76 to 86% efficiency by dialing in my pH. Now you might ask, if most brewers only reach 70 to 80% of maximum yield, why do we give a rat's ass about what the maximum yield is? As mentioned before, if you know the maximum possible yield, then you can compare the results you get from a particular malt on your own system and determine your extract efficiency. There you go. Knowing how to effectively calculate your malt bill on your own system means no more poking and hoping that you get the result that you wanted. You can now tweak in your flavors and still hit your intended gravity targets. I think we can all agree that ABV has a lot to do with the flavor of a beer. It's like cooking. A good chef knows what ingredients to add to make an entree taste like they want it to taste. Personally, as a brewer, I want to be able to do the same thing with the same preciseness. I want to feel like I'm in control to that level where I can add a little bit of something and get the result that I intended to get. So one more thing about sparging and efficiency. It's easy to think that you want to get every single trace of sugar off of your grain, but the fact is that there is such a thing as over sparging. Don't go past about 10-10. So once your runnings get to 10-10, it's time to cut it off, and your volume is your volume at that point in time. If you have missed your target, we're going to talk next month about hitting your targets on the fly and how to make up for that and calculate those differences. But I tell you, if you go past 10-10, you're likely to make a thin tasting beer. Okay, we're all done with our sparging process. We were shooting for 14 gallons of volume here, and as you can see in the sight glass, we're right about 14, just a hair under. And so why I stopped it is because I broke that 10-10 threshold that I was telling you guys about. I was down to 10-9, 10-8, and so I cut it. There are two gravities a brewer is concerned with on brew day. We all know original gravity. because it is a key factor in determining alcohol by volume. The other is boil gravity, which is the gravity you have once your lauter is complete, but before you have boiled. It is the boil gravity that you want to use to calculate your efficiency. It is also important to understand the concept that once you are done adding sugar to your worts, the sugar level stays the same. The concentration is what changes, and changes due to the evaporation or the addition of water. There is no way to boil off sugar content. You simply have more or less water that the sugar is dissolved into. Now it's time just to brew and figure out what you were able to extract on your own. Here is what my results were from my German pills. On this graph, you can see the maximum ppg for each malt that I added to my mash, and then you can see the aggregate of those numbers or the total yield. As you can see, the maximum yield I could get from my grain was 47.5, and what I got was 42.3. Now, to calculate my extract efficiency, I now need only to divide my actual yield by the maximum yield, which in this case is 89%. So my extract efficiency is 89%. And dig this, 89% is what I based my recipe on when I first made it. I missed my water fill by a little, and that delta can be explained due to the fact that I just used the general malt yield expectations that I showed you on slide 4, rather than getting the information sheets from the maltsters. And remember that you can get those sheets from the maltsters online and also at your local brew shop. Couple of key things to remember. First, most grain you mash is going to have a percentage extract of 60 to 80%, with darker malts being at the bottom of that range and wheat malts being near the top. There are plenty of fermentable sources that render 100% of their total weight as soluble. Sugar, DME, LME, honey all give you everything they've got. Extract or mash efficiency is a calculation that is very useful and can take you to another level of brewing. Now, with that said, it is based on your past experience and nothing more. When designing a malt bill, it's best to start low, 68 to 70%, but each time make note of what extraction you achieved. You cannot determine what your system's efficiency is with one brew day. It's only through multiple brew days that you will see a pattern and be able to zero in on what your typical yield is, and then use it as a number that is useful to you. Remember that extract efficiency will vary slightly from batch to batch, depending on many variables, including pH, water temp, the grind you got from the mill at the brew shop, etc., etc., etc. Therefore, controlling those parameters that can affect your efficiency is key. Once you have determined your typical yield, try tweaking with different parameters and see if they make a difference. As I mentioned before, pH made a huge difference for me. There are other factors that make a difference in your total brewhouse efficiency. Most of these are determined by your brewing system, and the level at which your brewhouse is affected by them will also be unique to your system. If you are having trouble dialing in your extract efficiency, look to some of these variables as possible causes. So the data that we presented to you here is really the science behind this topic, and no matter what type of system you use, this data can be used to determine your extract efficiency. And remember, no matter what kind of system you use, you can achieve a high efficiency rate. For me, it's not really about getting every ounce of starch out of every pound of grain, although that would be nice. It's really about knowing your system and what to expect from it. And so that way you can get creative with your brewing process and you're not surprised about what comes out on the other side. So all of the material in this presentation can be found in two sources that, in my opinion, are essential to every brewer's library. How to Brew by John Palmer and Designing Great Beers by Ray Daniels. These two books are incredible by themselves, but can be used in conjunction to great success. So I hope that you get something out of this material. It will be made available to you on YouTube or some other source for playback. Good brewing to you all. Thanks for listening. See ya.